In this video, we're going to be finding areas of four-sided shapes, or what are known as quadrilaterals. The area of any quadrilateral can be found using the following formula. You've probably heard of multiplying length times width to find the area. Length times width. In the next few videos, though, we're going to be defining length and width as two different words. We're going to call them base and height. And the reason we're going to do that is because it's more descriptive. We're going to be dealing with a lot of different shapes, and if we say base times height, we can cover a lot more shapes than just quadrilaterals. So try and get used to the area formula for a quadrilateral as base times height. We also have a special one for squares. Because the length of a square is the same regardless of whether it's the base or the height, then we can really just say that it's whatever the length of a side is squared. Multiply it by itself. You could say length squared or side squared. Either one, same thing. So for example, if we used something like 4, if we knew that one of the side lengths of this square was 4, all of them are equal, so this over here is 4. So base times height would be 4 times 4, which is why we're allowed to simplify it to 4 squared, the number times itself. And so the area would be 16 square units. You could say feet squared, you could say centimeters squared, or any unit squared. And the reason we get a square unit, let's take inches for example. If I multiply inches by inches, well then I get inches squared. And that's essentially what we're doing. We're multiplying our units by themselves, and we get a square unit. Alright, let's move into just any four-sided shape. This is a rectangle. You're going to see examples of all different kinds when having to find the area of a four-sided shape. I'm going to show you a few different examples of how they can make this a difficult problem. Sometimes they'll give you what is called the diagonal of the rectangle or the diagonal of the quadrilateral, and they'll give you one side. And so you're expected to be able to solve for the missing side here in order to multiply base times height. So let's say the diagonal is 17 and the base is 15. How are we going to find this missing side? Well, if we just focus on this as a triangle, a right triangle to be specific, then we can use Pythagorean theorem to find that missing side, and then we can find the area. So if we do 15 squared plus x squared equals 17 squared, 15 squared is 225, and 17 squared is 289. And let's subtract 225 from both sides, so we get x squared is equal to 64. And if we square root both sides, we get x is 8. So now we know our height of our quadrilateral here, and we know the base. So base times height will give us our area here. And so 15 times 8, well 10 times 8 is 80, and 5 times 8 is 40, so if we put that together, that gives us 15 times 8, which is 120. So the area of that quadrilateral is 120. So there's an example of using Pythagorean theorem to find a missing base or height in order to find the area. Another thing they might do is, again, break it up into two triangles, and they'll require you to use one of your special right triangle formulas to find a missing side. Say that they gave us the hypotenuse of this triangle, or the diagonal of the quadrilateral here. They gave us 20 as the size of that. They say that we have a 60-degree angle here, a 90-degree angle there because it's a quadrilateral. So that must mean that this is 30 over here to complete the 180-degree triangle. So now we have a 30, 60, 90 special right triangle. And we're missing both base and height. So we could give them variables if you really want. And then solve for each of those variables. Well, if you know the hypotenuse in a 30, 60, 90, the short leg, the side of the triangle that's across from the 30-degree angle, is the short leg. And that is always half the hypotenuse. If you remember that the short leg is half the hypotenuse, then that tells us that x is 10. And then if we have the short leg, the long leg is whatever the short leg is, times the square root of 3. So if the short leg is 10, that makes our long leg 10 times the square root of 3. And then now we got our base, we have our height. Our area would be those two things multiplied together, 10 times the quantity of 10 times the square root of 3. When doing math with radicals, we're only allowed to multiply numbers outside of radicals together. So only 10 times 10 on the outside there. Get 100, and we still have the square root of 3 attached. We could turn that into a decimal, and it's approximately 173. If you find the square root of 3, it's approximately 1.73. And if you multiply that by 100, you move your decimal point over 2 spots, and you get approximately 173. So either form, either in radical form or decimal or rational form there. So that was using special right triangles to find missing sides of our quadrilateral to find the area. One more example. They could ask us to use trigonometry. So let's say they gave us another hypotenuse of 12, and they gave us an angle of 46 degrees. Now, because that angle is not part of our special right triangles, we got to use trig now to find our missing base and height. So to find the length of our base here, x, we want the side opposite the angle, and we want to use the hypotenuse. So opposite and hypotenuse tells us that we need to use sine. So the sine of 46 degrees is equal to opposite side over hypotenuse. Find the decimal value of the sine of 46 degrees, either using your calculator or a trig table. And you should get something close to 0.7193. And in order to solve this proportion, we cross multiply. So x is whatever 12 times 0.7193 is, approximately 8.6. Okay. So we got our base, we still need our height. In order to find that, that is the side adjacent to our angle. So we know we need to use the adjacent side in hypotenuse. That tells us that we need to use cosine. Cosine of 46 degrees is equal to adjacent side over hypotenuse. So again, we're just cross multiplying. Find the decimal value of 46 degrees. It's approximately 0.6947. So when you cross multiply 12 times 0.6947, you get approximately 8.3. So 3 there. And so now that we have base and height, we can find our area. 8.6 is our base times our height, 8.3. And we get something close to 71.4. That's our area. So again, we used trig to find our missing sides of our quadrilateral so that we could find the area. So you may see several types of problems, each involving different things that you have to solve for before you can find the area. There's just a few examples. The last thing you might see when talking about area of a quadrilateral, you might see a shape that's not a quadrilateral. It's got many more sides than just 4. In order to find the area of such a shape, you can use 2 different methods. You can use the area addition method, and what you do there is you create quadrilaterals. You cut the shape up into 4-sided shapes. As many or as little cuts as possible is usually the most preferred method. It just depends. We could cut this right here to create 2 4-sided shapes, or we could cut it right here. It doesn't matter. Generally, it depends on what you're given in the problem and whatever's easiest to solve for. So let's give ourselves some dimensions here. Say that length is 5, this one up here is 8, that over there is 3, and 6 here. So the first step you want to do is create quadrilaterals, create 4-sided shapes by cutting things up with imaginary lines here. So let's cut this one right here. Again, it doesn't matter, we could have cut it vertically. If we do that, we have now shortened this side right here. It's not the total 5 anymore, we've cut it into 2 different lengths. We now have the same thing, opposite sides are equal in quadrilaterals, so this is 3, and in order to get a total of 5 from 3, we need to make sure that that is 2. So the total is still 5, but we've just chopped it up into 2 different lengths. Again, opposite sides of quadrilaterals are equal, so cross from over there is 2, right there as well. And we can figure out this missing length. It's not necessary, but we can still figure it out. The total length across this shape is 8, and on the bottom here we have most of it, we have 6, so what's left has to be this distance, or this length right here. So if it's 2, that would give us a total of 8, and we'd be alright. Now, second step, find individual areas. Find the areas of your smaller shapes here. So this is an 8 by 3 rectangle. That area is going to be 24. The area of the smaller rectangle down here, its height is 2, its base is 6, so multiply those together to get an area of 12. And the last step we need to do to find total area, add areas. Add up all your total areas there. So 24 plus 12 gives us our total area, or TA. 24 plus 12 is 36. And just to wrap things up here, I'm going to show you a slightly different method. We could use what's called the subtraction method. So let me get rid of some of this stuff here. If we found the total area, let's pretend that this shape went all the way across, and we just had this rectangle, this 8 by 5 rectangle here. Then the total area of that rectangle would be 40, 8 times 5, and then we would want to subtract this area to get the shape of our irregular shape there. And the area of this is a 2 by 2, so 2 times 2 is 4. So using subtraction method, we would take 40 and we would subtract this area, so 40 minus 4 still give us a total area of 36. So it's up to you. Sometimes the addition method is easier, sometimes the subtraction method is a lot easier. It just depends on the problem and the situation you have to deal with. So there you go. Good luck finding area of 4-sided shapes or areas of any quadrilateral.